All right, today we're going to tackle a concept that is literally everywhere. In math, in science, even in art. We're talking about proportions. And yeah, they might seem basic, but once you really get them, you unlock some seriously powerful ways to solve problems. So let's dive in.
So here's the game plan. We're going to start with the absolute basics, what a proportion even is. Then we'll unleash a little superpower called cross-multiplication. After that, we'll level up and start working with more complex expressions. And finally, I'm going to show you this awesome pro-level shortcut called the K method.
Okay, first things first. Before we can start solving anything, we've got to be on the same page. So what exactly is a proportion? What are we even talking about here?
At its heart, a proportion is really just a fancy way of saying two fractions are equal. That's it. It's a statement of perfect balance. It tells us that the relationship between A and B is exactly the same as the relationship between C and D.
Now, this might seem like just some boring vocabulary, but trust me, you're gonna want to remember this. The two numbers on the outside, A and D, we call those the extremes, and the two on the inside, B and C, are the means. Knowing these names is the secret key to unlocking the most powerful trick in our toolbox. And that brings us right to that magic trick I was talking about. This is your #1 go-to technique for proportions. Honestly, it's a total game changer, so let's get right into it.
This, right here, this one little sentence says it all. In any true proportion, if you multiply the two outside numbers, the extremes, you will get the exact same answer as when you multiply the two inside numbers, the means. It's a rule that never breaks.
And you can see exactly how it works here. We're literally multiplying diagonally across that equal sign, making a big X shape. And this is the real superpower. It instantly turns a problem with messy fractions into a simple, clean equation that's way easier to solve.
Okay, so that's the theory. But how do we actually use this thing to find a missing number? Let's put this superpower into action with a real example. All right, here we go. We've got our 3 known numbers and 1 mystery guessed, X. The very first thing you always do is set them up as a proportion.
And check out how smooth this process is. Step 1, you set it up. 4 over 12 equals 16 over our unknown, X. Step 2, you unleash the superpower, cross-multiply. So 4 times X equals 12 times 16. And from there, it's just a little bit of simple algebra. And boom, we get our answer. X is 48. It's a reliable system that just works.
Okay, time to level up. What happens when the pieces of our puzzle aren't just simple little numbers, but actual algebraic expressions? Well, you'll see that the core logic stays exactly the same.
No matter what the starting equation looks like, the goal is always the same. You just use your algebra skills to shuffle things around until you've isolated that ratio, in this case, x over y. You want to get it back to that comfortable fraction equals fraction format we know how to do with.
Ooh, okay, now this is a fun one. This is a great little challenge problem. We're not just looking for a missing number in a set. We're looking for one single mystery number that we can add to all 4 of these to make the new set proportional. Now, I know what you're thinking. That looks kinda messy, right? A little intimidating, but don't let it fool you. The logic is exactly what we've been doing. We just set up our 2 ratios, and now that we have a proportion, well, we know exactly what to do next, don't we? Cross-multiply. And would you look at that? Even with all that extra algebra to work through, the core process didn't change one bit. We multiply the extremes, we multiply the means, we set them equal, and we solve for X. And it leads us straight to our answer. The magic number is 5.
All right, now it's time for a really elegant kind of pro-level technique. It's called the K method, and it is a fantastic shortcut for simplifying some of the trickier problems and proofs you might run into.
The idea here is actually really simple. Think about it. If the fraction 1/2 is equal to the fraction 2/4, it's because they both simplify down to the exact same value, right? 0.5. The K method just gives a name to that shared value. We just call it K, our constant of proportion.
And this is where the magic happens. If we can say that A over B equals K, well, we can just rearrange that with a little algebra to say that A equals B times K. We can do the same for C. This lets us substitute and replace variables in really complicated expressions, which suddenly makes them way easier to solve.
And right here, this is the perfect example of its power. I mean, look at this proof. It seems almost impossible, right? These two expressions look nothing alike, but by replacing A with BK and C with DK and simplifying, we can show that both of these crazy-looking things, they both just simplify down to K. And just like that, proof complete.
So let's put this thing to a test. We're going to use the K method to solve a problem that honestly would be a real headache to try and solve with cross multiplication alone.
We start with this confusing jumble of equal signs. The first move is to get clever and rearrange it into a nice, clean proportion. Then we bring in our secret weapon. We set them all equal to K. That lets us define A, B, and C all in terms of that one single variable. We plug those new values into the other equation we were given, solve for K, and once we have K, it unlocks all our final answers. It's just so clean.
So there you have it. That's your complete proportion toolkit. When you boil it all down, it really comes down to these two huge ideas: the raw power of cross multiplication for most problems, and the elegant K method for when things get tricky.
So, I'll leave you with this thought. Whether you're scaling a recipe up for a party, reading a map to figure out a distance, or even looking at the architecture of an ancient building, our entire world is built on these hidden relationships. Now that you know the language, where are you going to see them next?